Hello, in this video we're going to talk about vectors. Suppose, as the book mentions, that you need to pilot a plane from this beach to Avalon in the island. If you were to, you know that this is 26 kilometers away. You see that 26 kilometers is not enough for you to pilot the plane. It's not enough information. You also will need to know in which direction to fly, which makes this a vector. What you require vectorial information, because going from here to here, right, it's a displacement, right? And displacement, as we mentioned before, it's a vector, because you need not only the magnitude, you're also going to need a direction. So let's say what you will do is you take a protractor and then you measure the angle. And then whatever angle this gives you, let's say this is the x-axis, this is the y-axis, we can see this is 90, 180, let's say it's 210 degrees. So you will say my displacement is, my change in position, which the book calls delta r, will be 26 kilometers and then at an angle of 210 degrees. When dealing with vectors then, as you saw right now, first thing we have to do is define a coordinate system. And the usual way to do this is to have a vertical line and a horizontal line. And this is the x-axis and this is the y-axis. So there are two ways to define the position in space. One is called the rectangular coordinates, in which you, for instance, you say, oh, well, I'm here, so 1, 2, let's say you're going to be 1, 2, 3 spaces in x, and then 1, 2, 3, 4. Let's say we are at 3 in x and 4 in y. So then you live here. And then that point P is defined as 3, 4. You know this very well from high school. Then the other way is to express this position in space as polar coordinates, in which instead of the x and y, what you define is the whole distance from here to here plus an angle. The angle is always measured with respect to 0 degrees, which corresponds to the positive x-axis. So how do you convert from one to the other? Well, we use trigonometry, right, in which we get this horizontal distance, right, and then we also get, let's say, let's use blue or some orange, and then also this distance, that's brown, okay? So if we use trigonometry, with a little bit of trigonometry, we can remember that the relationship in a triangle between this number and this number, this is 90 degrees. And this angle, we remember that sine of the angle is y over the hypotenuse. Cosine of the angle will be adjacent over the hypotenuse, and then tangent of the angle is opposite over adjacent. And when we can also remember that x squared plus y squared is h squared. So we have these 4 relationships, and that's all we need, because based on this we can say that x, which is this distance here, and y, which is this distance here, we can write x as r cosine of theta, and y, we can say it's r sine of theta. So to convert from one system to the other, let's say you start with the polar coordinates r and theta. Well, you use these two equations, and you can find x and y. If on the other side you start with the x and y, then you also can use these equations to find the angle, and r, the hypotenuse. To find the angle, you can say that the tangent of the angle is x over y. And to find the hypotenuse, you can just do x squared plus y squared square root. So let's practice with this little example of what I told you before. Here we have the Cartesian coordinates and we want polar coordinates. So as we said before, well, one good thing to do will be to draw something first. We have minus 3.5, so minus 1, minus 2, minus 3.5, and minus 2.5. Okay, minus 1, so we are around here. Okay, this will be the point minus 3.5, comma, minus 2.5. So the vector we're trying to find, the position vector we're trying to find, goes from here to here. Well, that's an ugly arrow. That's an ugly arrow again. This is very hard for me to draw properly. There you go. There you go. That will be the r, and the angle, as I said before, will have to go from 0, which is here, up to the thing, and here we're measuring the angle positively. To measure the angle, if the angle goes like this, that's positive. If you measure the angle like this, it's negative. So clockwise and counterclockwise. Good. So the equations tell us that x, and so if you want the angle, first we can find the hypotenuse, right? R will be x squared plus y squared, square root of that, so minus 3.5 squared plus minus 2.5 squared. Everything is in meters. So, and then square root of this, and the value we get is 4.3. 4.30 meters. So that's the hypotenuse, right? If I put the coordinates here like this and like this in the triangle we just found, the hypotenuse of this right triangle. And then to find the angle, well, look in this triangle that I just wrote here. This was r, this was x, and this was y. Let's find this angle alpha here. Remembering the tangent of alpha will be y over x. So alpha will be arctangent to the minus 1 in your calculator, y, which is minus 2.5 in y, minus 2.5 over y, which is 3, my goodness, over x, excuse me, 3.5, there you go. And this gives you an internal angle, so this gives me 35.5 degrees. That's what angle we will have inside this triangle from here to here. But we always need to represent the angle with respect to 0. So that means we need to add 90 degrees plus 90 degrees plus 35.5. So the angle as measured from 0 is positive 90 plus 90 plus 35.5. And this will mean 216 roughly degrees. Notice that alternatively, you can always say that the angle is negative this number here, which will be negative 90 and plus 90, 180 minus, so that will be a negative 90 plus 90 minus 35.5. So negative 100, oh my God, 144.5 degrees. This was 215.5, okay? So notice that 215.5 plus the 144 gives you the gives you 360 degrees. Okay, so it's either plus 215.5 or minus 144.5. This is the end of this short video. In the next one, we're going to talk more about vectors and scalars.